Welcome. In this tutorial, we are going to take a look at the advanced features that BlastBullets2D offers. Just like I mentioned in the last video towards the ending, we need to use the spawn controllable directional bullets function and save the instance in a variable. Now we have full access to all advanced features. Let's first talk about BulletCurves. This is a feature that allows you to replace the bullet speed data and the bullet rotation data with actual Godot curves that are visible in the inspector. It makes it super easy to see how the speed and rotation change as time moves on. Let's create a BulletCurves data custom resource so you can see how it works. By double-clicking on the resource, you're going to see a bunch of properties inside the inspector. We are going to focus on only one of them, the movement speed curve. By creating a brand new curve and adding points to the graph, we are essentially setting how the speed of the bullet will be affected during its lifetime. The x-axis represents the time, meanwhile the y-axis represents the speed value that the bullets will have. A very important thing you should know is that currently by default the x-axis is not in absolute time values. We are using a unit curve with normalized values currently because the movement use unit curve property is set to true. When this property is set to true, 0 represents the beginning of the lifetime, exactly when the bullets are spawned, and the value 1 represents the ending of the lifetime, not an absolute value. If we want more control over this and represent the time in absolute values, knowing exactly at which second what should the value be, then we need to set the movement use unit curve property to false. Edit the max value, which is the y-axis and represents the speed, and start placing points on the curve. With left mouse click you place the points and with right mouse click you remove the points. You will play around with the other properties of this custom resource. For now, let's go back in our player script and set this curves data to our bullets. First, load the resource and save it to a variable. Next, we have two options. We can either set the shared bullet curves data so that every single bullet in the multi-mesh has the same curves data, or we could use the bullet set curves data to set a specific bullet's curves data. After launching the game, you'll see that the bullets will act just the way you define the curves in the inspector. This is all you should know for the BulletCurves feature. Let's move on to the next one. Movement patterns. This feature is very powerful. It allows you to use the Path2D node and draw movement patterns that a bullet will follow. You could use this to make zigzag patterns or other custom patterns you may think of. Let's see it in action. First, go in the main scene and make a node where we will store our Path2D patterns. Create a new Path2D node. Use the controls at the top to add or remove points in 2D space. Draw a very short pattern. There is no need for you to draw a long one since the plugin can handle the repeating of the pattern for you. After that, add it to your global script as a static variable since we want it to be accessible. Make sure the static variable actually does hold the Path2D reference. Now, go inside your player script and use the set bullet movement pattern from path or all bullets set movement pattern from path to set the movement pattern. You can set whether the bullet should face the new direction and whether the pattern should be repeated. Play the game and see the results for yourself. Now it's time for one of the most exciting features, homing bullets. This feature allows you to have bullets that track enemies and move towards them, chasing them. Let's first configure it. First most important property is homing take control of texture rotation, which needs to be set to true. Next, homing smoothing, which controls the rotation smoothing. Homing update interval controls how often the new position of the enemy target is acquired. Homing distance before reached is the distance required away from the target before it is considered as reached, and when the target is indeed reached, the bullet homing target reached signal is emitted, where we can place custom logic on what happens after that. These are the main properties you should configure. The homing functionality allows you to target, node to the enemy targets, global positions, and also track the global mouse position. It is an extremely flexible system. Now, how can we add homing targets? Just like every other feature we've seen until now, we have two options, shared homing targets or per bullet homing targets. If we want all of the bullets in the multi-mesh to target the exact same targets, we have to use the shared homing deque pushback node 2D target. Otherwise, we use the bullet homing pushback node 2D target or all bullets pushback homing target. There are so many helpers, you check them out yourself and use the ones you need. The homing functionality is based on a double-ended queue. This means each bullet can hold a bunch of targets that it should track, and we can choose to pop them off once they're reached. That way, the bullet will move on to the next target. Since this is such a common thing, I've actually exposed two properties that will help you with this being done automatically. The bullet homing auto pop after target reached and the shared homing deque auto pop after target reached. One is for the per bullet data structure and the other is for the shared data structure of targets. You can get some node 2Ds that you want to track, like maybe the enemy container's children, and just push them to the deque. We could also make it so that the bullets track the global mouse position. Play the game and see for yourself. Let's take a look at our next feature, orbiting bullets. You see, the bullet homing functionality is so powerful that it allowed me to implement an orbiting functionality right out of the box. The orbiting bullets logic works hand in hand with the bullet homing. You cannot have bullet orbiting unless you have enabled the bullet homing first and you're tracking a homing target. It doesn't care if you're using the shared bullet homing or the per bullet homing data structure. It only cares whether there are homing targets. Use the bullet enable orbiting or the all bullets enable orbiting function. You're able to set a radius which the bullets will respect and orbit around, and an orbiting direction as well as what the bullet should face when orbiting. Again, a super powerful feature that you can play around with. Bullet attachments. This is the ability for the bullets to carry other node 2Ds as they move. Imagine you want to attach GPU particles or a custom node 2D or maybe even much more than that. Well, my plugin supports even this. In the example project, we have some particle scenes that we can use as an example. Our goal is to attach them behind the bullets as they move. Inside a new folder where we will store our attachments, create a scene that is of type bullet attachment 2D. This is incredibly important. Add the GPU particles inside and make sure that they are positioned at the center without an offset. Go inside your player script, load and save this particle scene into a variable. Then use the bullet set attachment or all bullet set attachment to attach it to the bullets. Note that just how the multi-mesh bullets use an object pool, the same optimization is made to the bullet attachments. So anything you attach to the bullets is also being pulled and reused instead of freed. In order for pooling to work correctly, you need to provide an attachment ID. This is the ID of the object pool from which attachments are being reused. For each packed scene that you preload, you need a different attachment ID. Another thing is you can set the offset of the attachment relative to the bullet texture center. This allows you to position the attachment correctly. If you play the game though, you will notice something weird. When the bullet's lifetime is over, the attachments do not disappear and instead just stay inactive. We do not want it to be visible during this time period. You might think to yourself, well, I'll just go to where I handle the bullet collisions and I'll just detach the bullet attachment and then free it. This is perfectly valid option. You have the full flexibility to do this and sometimes it is necessary. However, we do want to take advantage of the attachment auto pooling since we avoid freeing nodes and this helps with performance. This is where the documentation of the bullet attachment 2D comes to help. I expect the user to have a bunch of custom logic and I want him to have full control over how the bullet attachments behave. You have the option of overriding a bunch of functions. What happens when you spawn the bullet? Is the attachment visible or not? Do you need to set some variables? What happens when the attachment is disabled? Should you make the node invisible and disable processing to gain performance and so on? You are the one in full control, so take advantage of this and configure it however you want. Since we started talking about object pooling, what if you didn't want this feature on? Well, since we know that all advanced features can be controlled, we can turn it off by setting the is attachments auto pooling enabled to false. Another cool thing is that we can also disable the multi-mesh bullets object pool so that we truly have full control over the bullets. We do this by setting isMultiMesh auto-pooling enabled to false. This is useful when we want to store the multimesh instances into an array and sort of implement our own pooling logic, activating certain bullets, disabling them, and so on. If we were to store the multimesh instance in an array without first disabling the auto-pooling, then we would run into the risk of saving the same reference of bullets twice, or maybe more. This is because the spawn functions either reuse an existing multimesh from the pool, or they create a brand new one, and we never know which one it is. Alright, let's see the next feature. Although not as impressive as the other ones, it is used a lot in bullet hell games. Multiple collisions. This is the ability for your bullets to collide multiple times without getting disabled. To configure it, just use the bullet max collision count. Note that it's probably a better idea to set it inside the bullet's data itself, not during runtime on the bullet instance after it gets spawned. Okay, I think you've all seen just how powerful BlastBullets2D is. It has a bunch of features that take care of so many problems you might experience, and it also saves you a lot of time from implementing them from scratch. But we also need an easy way of modifying all these properties during runtime, right? What if you wanted to suddenly change the speed of the bullets, or maybe make them have rotation data instead? What if you had orbiting bullets but you want to edit the orbiting radius, or you want to add new homing targets? Or maybe switch the movement pattern to another one? Sure, you might disable the auto-pooling, store them in an array, and modify them however you want, but what if you wanted to depend on time? This leads us to the last main feature that BlastBullets2D provides: attaching time-based functions. This gives you the ability to attach functions that get called after a certain period of time. The calling of these attached functions happens automatically during an idle frame to avoid issues with the physics processing and collisions. This is much better than using the scene tree timers. It also gives you the ability to repeat functionality over and over. To use this feature, just call the multimesh attach time-based function and provide the function callable. You're also able to detach the functions you've attached as long as they have a name and are defined outside. Physics interpolation. If you're targeting devices above 60 Hz, it is a good idea to turn on this feature. Go inside the Bullet Factory 2D and just tick the checkbox. Also, in the project settings, make sure physics interpolation is enabled. That's all you need to do. Now your bullets will always look smooth. These were the main features of my BlastBullets2D plugin. I really hope you find it useful for your games, and I would really appreciate it if you could give me an honest opinion in the comments. I really do believe that my plugin is the most advanced option out of everything else you might find online, and it is completely free and open source. You can support my future projects on Ko-fi and Patreon. Make sure to give a GitHub star to the repository of BlastBullets2D if you find it impressive. Goodbye, and I'll see you in the next one.